Hey, good day everyone. My name is Chai Shen and my matrix number is 286040. Today I would like to discuss about how I solved my question 1 for my individual assignment of Calculus 1. The question given is to discuss and sketch the function fx is equal to cotangent x where the interval is between 0 and 2 pi. For solving the question, there are 7 steps to do. We need to find the x and y intercept and open interval where the function is decreasing and increasing. X coordinate of the inflection point, vertical asymptom, open interval where the function is concave up and down. Find the local minima and maxima, and last we need to sketch the graph of the function. First, to find the x-intercept, we need to let fx is equal to 0. And when the cotangent x is equal to 0, x is equal to pi over 2 and 3 pi over 2. Then we need to substitute 0 into cotangent x to find the y-intercept. In this case, we will know that there are no y-intercept because it is undefined. Okay, the second step is to find the open interval where the function is decreasing and increasing. We need to find the first derivative of fx when f prime x is equal to 0. X is undefined. That means the function doesn't have the stationary point. Then we find the function and is increasing or decreasing. We need to substitute pi over 2, 3 pi over 2 into f prime x and get the answer of -1. That means the function is always decreasing and when it is less than 0. Okay. In addition, to find the x-coordinate of the inflection point, we need to determine the second derivative of the function and we will get the answer f prime prime x is equal to 2 cos x over sin cube x. Next, let f prime prime x is equal to 0 and get the answer x is equal to pi over 2 and 3 pi over 2. Next step, we can find the vertical asymptom by letting the fx is equal to 0. So the cos x over sin x is equal to 0 and obtain the vertical asymptom equal to 0, pi, and 2 pi. The step 5 is to determine the open interval where the function is concave up and down. The diagram and table shows that the second derivative of the function in the interval between 0 and pi 2 is positive and it is concave up, while when the interval is between pi over 2 and pi is negative and concave down. Next, when the interval is between pi and 3 pi over 2, it is positive and concave up, whereas when the interval between 3 pi 2 and 2 pi is negative and it is concave down. In step 6, the function doesn't have any critical point, so they have no local minima and maxima. At last, the right hand side is the graph that I sketched based on the information above. That's all for me. Thank you.